At first, we'll give a definition of machine translation. The term machine translation refers to computerized systems responsible for the production of translations with or without human assistance. Sometimes it was considered as automatic translation, which was a term used to refer to translation that is performed wholly or partially by computer. Here is a timeline of machine translation development. As early as 1950s, Georgetown University and IBM has conducted a successful experiment on machine translation. And then rule-based machine translation was development. It includes dictionary-based machine translation, transfer-based machine translation, and interlingual machine translation. And 30 years later, exam-based machine translation was proposed. 10 years later, statistic machine translation has become significant, successful. And in 2015, neural machine translation has replaced statistic machine translation. So in 1950s, computer scientists began attempting to tackle the problem of machine translation. Georgetown University and IBM carried out the first published machine translation experiment. So it was initial efforts, and it relied on linguistic rules to analyze a source sentence and generate intermediate representation, from which the target language sentence was generated. Such approaches are useful for translating across languages that are closely related. As for rule-based machine translation, it is composed of enormous libraries of rules built manually over time by experts in translation. They mapped structure from the source language to the target language. So this cost is expensive and time-consuming. Also, as rules are introduced and changed, there is a risk of ambiguity and degradation in translation products. Therefore, language experts are needed to apply language rules to the system in rule-based machine translation system. Dictionary-based machine translation, transfer-based machine translation, and interlingual machine translation are examples of rule-based machine translation approaches. At first, example-based machine translation is on the basis of the concept of analogy. It will search for similar examples of sentence pairs in the source and target languages, because examples are taken from a vast collections of bilingual corpora. So exam-based MT also falls within the category of corpus-based techniques. Therefore, if we can have the source sentence with similar substantial components will be extracted from the bilingual corpus, and the translations in the target language will be used to produce the entire translation of the phrase. Now, let's introduce a little bit more about statistic machine translation. Its foundation is statistic techniques, so it can also be classified under corpus-based methodology because we need extensive bilingual corpora as a data source for statistic processing procedures. But no language expertise is necessary to build a statistic machine translation system. It will make use of statistic models developed through the examination of tests, whether they are bilingual or monolingual. This data is known as training data. Better and powerful MT systems will be created if there are more training data. So construction and storage of statistic MT systems is very expensive in terms of computational processing power. Therefore, if there are enough bilingual or monolingual data from that domain, statistic MT can be easily applied to that domain. There is also one type of hybrid machine translation. When statistic methods continue to dominate MT research, most commercial MT systems have always been rule-based. However, the borders between these two approaches become slightly difficult to draw. It is blurred. So hybrid approaches have evolved. It attempts to benefit from both approaches. Hybrid machine translation are guided by rule-based machine translation, also by statistic techniques. So hybrid systems will use statistic MT to select the set of relevant translation candidates and to merge partial translation into the final sentence in the target language. This whole procedure is also guided by rule-based machine translation. So rules are also used in pre and post-processing stage of a hybrid system. We mentioned neural MT. It replaced statistic MT because it has advantages, such as it can use a deep learning-based method to make use of sizable neural network, which is built on word vector representations. In contrast to statistic MT, there is only one sequence model that predicts one word at a time, with no separate language model, translation model, or reordering model. So the source sentence and the already written sequence in the target language will serve as a basis for the prediction. Given that neural networks share statistic evidence between related words, the predictive capability of neural machine translation is more promising than any statistic machine translation system. Now, we'll introduce the features of these major approaches we just introduced. First, a dictionary-based MT. It will search a dictionary for equivalent words in the target language, then applies grammatic rules. As for transfer-based machine translation, it will transform the source sentence into an intermediate, less language-specific structure, which then will be transferred to a similar target language structure, from which the finalized target language phrase will be generated. So this method employs morphologic, syntactic, and/or semantic information from the source and the target languages. As for rule-based MT system, it is made up of huge libraries of rules created manually over time by language and translation experts. So these rules translate linguistic structures from one language to another. It is for sure expensive and time-consuming to implement and manage. Sometimes there is a possibility for ambiguity and a translation degradation as rules are added and changed or amended all the time. A standard rule-based machine translation contains, in addition to grammatic, lexic, and stylistic rules, software required to process these rules and a considerable number of bilingual dictionaries for each language pair. However, it has some advantages, like it can enable deep syntactic and semantic analysis of a body of text, even though it does need extensive knowledge and a large number of rules. The experiment we mentioned earlier, conducted by Georgetown University, and the previous version of system are examples of RBMT systems. Here is a procedure of example-based MT. The call transfer from source language to target language involves the decomposition of the source language into fragments, and then the matching of these fragments against a database of bilingual examples. And then these fragments will be recombined to produce equivalent of target language fragments. So the database of example-based machine translation systems are derived primarily from bilingual corpora, and they will be prepared by human translation experts. Also, they have to be pre-processed to be appropriate in forms for matching and extraction process. And the process of decomposition and recombination are designed to prepare source tests for matching against the database and to produce tests from database output. For statistic machine translation, it analyzes multilingual corpora using a statistic technique. So an SMT system employs many big corpora in order to identify statistic patterns and rules that can later be utilized in the translation profession. Therefore, its main disadvantage is that the large volumes of data must be processed on the fly, make them computer resource intensive. So it needs a large amount of computer power. Therefore, statistical models makes use a huge number of options, and they are known as hypotheses. Each hypothesis will be given a score. The system will choose the best score, which means this is most likely to be the correct translation. It has a few advantages over rule-based MT. For example, it can avoid the procedure to make difficult choices. We can choose the best score. And when it is going to process unexpected input, rule-based systems perform better than those that the speed has to be sacrificed for quality. However, in the meantime, it also has some disadvantages. For example, data were needed to train these model parameters. And then handling structurally rich models will be difficult. And also, the decision-making process is difficult to comprehend for users. Neural machine translation systems are more effective in learning representations. So they have advanced the state of art by building a single neural network. It consists of two parts. One, decoder. Second, encoder. The decoder network will create the translation, and encoder network will turn the input system into a series of representations. So on the basis of a single sequence model that generates one word at a time, NMT uses vector representations for words and internal state. So the transcription of words creates a vector with distinct magnitude and direction. where this section is about computer-aided translation. The main function of it is to help users to translate the text more quickly and consistently. So it will save the translation sentence by sentence, or we call it segment by segment, to store them in a database known as translation memory. So in the future translation, these records can be reused. Also, in the translation memory database, each translated segment will be saved along with its source text. We call it a pair. It is translation unit. So each time the same source segment is encountered, the translation content in the translation memory will be matched and suggestions will be made to the translator. So if the match is fuzzy rather than exact, for example, the new sentence is similar but not identical to the one in the translation memory, the target segment stored in translation memory will only be offered as a suggestion, which the user may need to edit before it can be accepted. As for the development of CAT tools, they are sophisticated computer programs that permit human translators to translate more quickly and often with a higher level of consistency, because the previously translated fragments are stored in the database. And it also provides a term base to make sure the consistency of term translation. As early as 1980s, when several companies started to develop alternatives to machine translation in the form of translation aids, such as terminology databases and translation memories. The first commercial systems, including IBM Translation Manager, Arch Deja-Vu, Star Transit, and Trados. They started to appear in the 1990s. So the technology has been gaining in popularity ever since. Nowadays, there are a few state-of-art CAT tools in the market. In 1994, Trados released a Windows version. You can try it in later workshop to install a Trados free version. It quickly made a system the industry standard. So in 1997, Microsoft bought a 20% share in the company. And later on, this company was acquired by SDL. And then in turn, it was bought by TWS in 2020. In summary, over the years, the number of translation memory tools has developed a lot. Recent years, we have seen further translation tools enter the market. So besides the original above mentioned system, the market has been joined by others, such as MemmaSource, now is Phrase, WordFast, MemmaQ, and WordB. For features of CAT tools, first, let's look at the core components of CAT tools. The first thing is it provides editing environment for translators to work on. We can type with a source text beside it, and the translation on the way, we can always preview our translation. And the most important function, translation memory, also term-based function to organize our terms, and then dictionaries to check our spelling, to give our suggestion about words spelling. Then it also can filter some files. So the filters can be used to import and export files in different formats. Also, Captures can also be combined with different machine translation engines. And nowadays, there is cloud-based server technology. So to compare captures with empty system, a capture merely supports the translation, and the translator translates the text himself or herself, while a machine translation system translates the text itself. Possibly we have to give it some file as input. So in the process of translation, a capture can make use of suggestions from a machine translation system, just like what we have tried in the last workshop. We can set the capture to make use of machine translation engine, and then the content will be pre-translated for us. So a capture can also analyze a text against the content of its translation memory, which will calculate the proportion of exact matches. Sometimes it is only fuzzy match, and the internal repetition that it contains, and then this information will be used to calculate what to change the client and how much to pay the translators. As for the editing environment, it is friendly, and we can use this enriched text edit to type in to revise the content. So users can translate files in numerous formats without any difficulty. As for translation memories, it can store source sentences with the translations as one unit. So the translation content in the translation memory can be reused and can be exploited in the future. For term basis, it can store single words, terms, or even phrases. And we can add terms specific to some organization, product, or customer. For dictionaries, their main use is to check our spelling, but there could be other possible usage, like to suggest the spelling and retrieve segment, and then we can look up meanings from the dictionary. File type features can permit users to translate a lot of file formats, such as PowerPoint, HTML, document, PowerPoint. And the features only show translators the translatable text and then reassemble this translated file on export. For machine translation engines, usually they are external. It will provide a draft translation of segments for which, even though there is no match in the translation memory, there could be a draft translation given by the machine translation engines. However, if you want to use a machine translation tool, maybe you have to make some payment first. They are not free, most of the cases. One important feature of cloud-based translation tools is we need a web interface to translate our documents. So we need internet connection, but we do not need to install it beforehand to our desktop computer. So this web portal will give us the ability to upload, track, manage all of our files and the projects from one single location. And it can use real-time tools like translation memory, and a cloud-based solution also can enable editors and translators to update in real time. So the advantages of cloud-based translation tools is for our localization process, it will combine the advantage of cloud server with a standard capabilities of a translation management system. So the benefits it can provide include the workflow of the cloud-based tool is ready to use, even though sometimes we have to customize it. We will make the localization process simple to implement according to our own needs. The most important feature about it is it provides simple access for any computer to our translation platform. We just need a working internet connection. Also, if there are much server strategy, there is increased protection against data loss if there is a system failure. So scalable cloud-based server is very flexible. It will adjust to our translation and business needs. Also, it saves a lot of cost because the provider of the cloud-based translation tool handles everything. We do not need to spend more money on complicated and expensive internal infrastructure. So this is a CAD tool we have tried in last workshop. We can find it is cloud-based and we can access it from any computer, provided that we have the right account and a password. We can log in and we can check our project and files for any computer if there is an internet connection. For translation memory, there are two different modes. The first is interactive mode. When translate test segment by segment, the TM tool is searched for identical or similar segments. The identical ones will be called exact match. They will be generally pasted into the translation editor directly, while others, fuzzy matches, will be presented in a separate window. So the translator can accept, modify, or reject the suggestions made by translation memory. The second mode is automatic or pre-translate mode. When the tool automatically processes the complete source text and inserts all the matches it finds from the TM into translation. So this mode is more useful if there is a lot of repetition. So you don't have to process each segment separately. It can save the manual effort. In addition, a CAD tool divides text into segments. It could be sentences or short fragments of text. So they will be presented to the translator in a way to make translation easier and faster. All in all, it can ensure higher quality translations. So use a CAD tool and translation memory that have been created will lay the foundation for our future translation work. So when our translation proceeds, the translation memory will grow and it will become more useful. So when a translation memory is used to translate a new file, terminology, different levels of TM match, and empty suggestions can also be displayed segment by segment for the translator to make use of. So for the translator, he or she needs to check these suggestions and decide whether to use them before or change them to edit them. So the decision will be easier. Through its features, a CAD tool can prepare and segment tests for a large number of file formats. So this allows translators to work with a specific file type, even if they don't know how to use the software to which the file type relates. For example, InDesign. So when the translation is completed, the CAD tool will reassemble the original file prior to any final checking, and the file will be sent back to the client. Therefore, the whole procedure improves efficiency, also ensure consistency and save cost. So when the document contains high repetition rates, repeated segments only need to be translated once, and this tool can propagate the translation to all jobs in the test. So some CAD tools are currently available as desktop system, and some tools are available in the form of cloud-based software. And software as a service are by now much more widespread than desktop systems, especially for large-scale translation companies. They prefer server-based editions because they can permit multiple team members to collaborate on a project. Sometimes desktop versions of MacBook are still not that popular. Also, some tools can permit translators to work on the text strings from an application's interface and to preview its translation. So once this translation is completed, a new version of the application will be generated from the localized strings. We call this procedure localization. CAD tool also has one function called assurance. It helps to detect. So errors can be prevented from occurring during the translation process. It will give warnings to the user about untranslated text, spelling errors, incorrect numbers, missing terms, unconfirmed segments, and so on. And the translator has to fix these warnings before they can confirm the next segment. Cloud-based translation tools also enable us to seamlessly integrate our localization process with internal team systems and tools. So such tools may include Dropbox or Microsoft OneDrive for cloud storage. Also, WordPress and HubSpot for website content, and GitHub for file repositories. There are some additional features about CAD tools, such as you can search and replace some content, and you can conduct concordance search to search the translation manually. Also, you can use it to align text, and it will create a new translation memory from existing translations. To summarize, the benefits of a CAD tool include enhanced quality of a translation, also improved productivity of translation, and better consistency of translation. And they can be widely applied into a lot of platforms, and it can provide easier access to the translation from any computer, provided that there is a connection. Also, it can be integrated with other cloud-based tools, and in the end, it saves a lot of cost. So to summarize our seminar, we have introduced the major approaches about machine translation systems, such as rule-based machine translation system, like dictionary-based MT, transfer-based MT, and interlinear-based MT. Also, we introduced exam-based MT, statistic MT, and in the end, we introduced neural MT. Also, there are some major catchers on the market nowadays, such as MemmaSource, MemmaQ, Chordo Studio, STM Cloud, Deja Vu, WaterFast, WorldB, and MateCat. Some of these provide free version, and we can try them in our workshop later on. Okay, that would be today's seminar.